The Tonga Volcano eruption creates mysterious and puzzling concentric ripples in Earth's atmosphere. That's how strong it was. This is still ongoing. It's code red 5 out of 5 eruption. And of course, with the eruption, we have the ash cloud full of sulfur dioxide. This is on Out of Mind 2. Scientists racing to understand puzzling series of massive ripples in Earth's atmosphere triggered by the eruption of the underwater volcano of Tonga. Satellite data shows that the event, which some fear might have devastated the Pacific island nation, provoked an unusual pattern of atmospheric gravity waves. Previous volcanic eruptions have not produced such a signal, leaving experts stumped. Lars Hoffmann, atmospheric scientist at the Jülich Supercomputing Center in Germany, says, "It's really unique. We have never seen anything like this in the data before," he said. The discovery was made in images collected by atmospheric infrared sounder AIRS for short. It's mounted on NASA's Aqua satellite in the hours after the eruption of the Huma Huma volcano that happened January 14th. They show dozens of concentric circles which represent a fast-moving wave in the gases of the atmosphere stretching from more than 16,000 kilometers. And the waves reach from the ocean surface to the ionosphere, and researchers think that they probably passed around the globe several times. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Nice concentric wave patterns. This instrument has been operating for something like 20 years now, and we have never seen such nice concentric wave patterns, Hoffman said. Atmospheric gravity waves occur when the air molecules in the atmosphere are vertically rather than horizontally disturbed in the air column. And this can happen as when wind picks up speed as it rises over a mountaintop or as a result of convection in local weather systems. The up and down waves transfer energy and momentum through the atmosphere and often show their effects in the way in which they cause high clouds to form in a series of ripples. And the images are from the atmospheric infrared sounder, NASA's Aqua satellite. It shows dozens of concentric circles, which are fast-moving atmospheric waves. In theory, the rapid updraft of hot air and ash from an erupting volcano into the upper atmosphere could trigger gravity waves on a much larger scale, but nothing like this has ever been observed with previous eruptions analyzed since the AIRS instrument was launched May of 2002. That's what's really puzzling us, says Corwin Wright. He's an atmospheric physicist at the University of Bath in the UK. He says it must have something to do with the physics of what's going on, but we don't know what yet. He and his co-workers suspect that a great big messy pile of hot gases in the upper atmosphere might be what kicks the waves off. The hot gas is going up high into the stratosphere and knocking the air around, he says. Or the atmosphere's composition has fundamentally altered electrochemically in recent decades, producing novel effects. And this brings in mind chemtrails, for example, which are most jet contrails lingering longer in the atmosphere than they used to. The eruption was heard across the planet. The eruption of the Tonga submarine volcano was heard across the South Pacific and even in parts of the United States. Ash has covered many regions of Tonga, but a loss of power, phone lines, and internet connectivity has made it difficult for aid agencies to assess the extent of injuries and damage, and the devastation, of course. Wright, who was the first to spot the wave patterns in data supplied by Hoffman, says that the images show what looks like a mixture of wave sizes and types. The convection in the atmosphere seems to be, quote, very complicated and bumpy, and it's generating a whole family of things at the same time, he says. He says that is what we currently think is going on, but we've only been looking at it for a few hours. The discovery was prompted by a tweet sent to Wright on January 15 from Scott Osprey, a climate scientist at the University of Oxford in the UK, who asked, "Wow, I wonder how big the atmospheric gravity waves are from this eruption." The explosive speed, Osprey says that the eruption might have been unique in causing these waves because it happened very quickly relative to other eruptions. This event seems to have been over in minutes, but it was explosive, and it's that impulse that is likely to kick off some strong gravity waves, he said. So the eruption might have lasted moments, but the impacts could be long-lasting. Gravity waves can interfere with the cyclical reversal of wind directions in tropics, Osprey says, and that could affect weather patterns as far away as Europe. We'll be looking very carefully at how that evolves, he said. The imagery and data collected from the eruption has been spectacular and has presented scientists with an exciting opportunity, says Vicky Ferrini, maritime geophysicist at Columbia University in New York City. She adds that she and others remain deeply concerned for the people of Tonga, particularly given the absence of so far of detailed information on the scale of this disaster. Researchers in New Zealand say that they are closely monitoring the volcano for further eruptions. Shane Conran, volcanologist at University of Auckland, says, "We are just keeping our ears to the ground. The volcano could be resupplying with large amounts of magma from deep underground and produce more explosive eruptions," he said. But if that has exhausted its main supply, it might produce only smaller eruptions, largely hidden beneath the surface of the ocean. The Tonga eruption and acid rain and cooling effect. It's possible the Tongan volcanic eruption could lead to a slightly cooler winter due to the huge quantities of sulfur dioxide released into the air, which bounces some of the sun's radiation away. The Tonga eruption, not nearly as large eruption as Pinatubo, would not have a global impact on the climate, but there could be some local effects in the southern hemisphere. It would mean that it might be just a little bit cooler than normal. Dr. Salinger said it could take a few months to kick in and have a cooling of about 0.1 to 0.5 degrees Celsius, lasting until spring. NASA said early indications from the Tonga eruption did not show extreme levels of sulfur dioxide in the stratosphere, but some of the sulfur dioxide has been wrapped into Cyclone Cody, east of New Zealand. Sulfur dioxide is a toxic, invisible pollutant, so for those in Tonga, this would cause short-term hazards to human health, including acid rain and volcanic smog. And this is by NWO Report. It's on Out of Mind 2. Please leave your comments. Thank you for your support.